Okay, so I'm going to come back. We're going to do the last one. I'm going to give you time to make sure you get caught up because the table has to be complete as well. So we drew the diameter CD and we drew the chord EF. Okay, they are both chords because both of the endpoints are on the circle. But the difference between EF and CD, write this down, is that a diameter is a chord, and I'll scroll it up, that goes through the center. Okay? You can list definitions, theorems, or rules. So basically, what does the diameter do to the circle? Yeah, cuts it in half. So we can add on here, cuts in half. It cuts the circle in half. Also, does anyone know another relationship for the diameter? We had to write a rule on our parts of the circle notes. Yes, write that down. Radius times 2. 2r is equal to that diameter, that d. Add that down as well. Now, our chord, which was our blue segment, is just a line segment. Now pick up the green. Line segment with endpoints on the circle. And I ran out of room. So I'm going to put a circle with the dot in it. That's the symbol for circle. So on the circle. All right, so chord does not have to be through the center. Diameter does. Chord just has to have the endpoints on the circle. So add that in your table. Our secant, and that was my green line. A secant is a line that intersects the circle at 2 points. We have to have 2 points of intersection for a secant. So I'm going to let you get that added as well. So understand, on the one that I drew, our secant is coming from the point L. That's the point outside the circle. Okay? And it is going through point E. Then it touches the circle again, and I'm laying that point in. Those are my 2 points of intersection. So you need to see 2 points of intersection for it to be a secant. Here, it went to G, actually, my C with the diameter, and then it goes to H. Are we okay there? So you have to have 2 points of intersection for secant. Radius. Our radius went from, let's say, a segment from the center to the edge or circumference of the circle. I'm just going to do the symbol. A circle with the dot in it is a symbol for circle. So a radius has to go from the center to the edge, and it's a segment. And we drew our radius doing that so that it crossed the GH part. Okay? All right, the last one we're going to do is a tangent. I'm going to give you the description first. Let me give me a different color here. Can never get to purple. Maybe that'll work. It is a line that intersects the circle at exactly 1 point. Only 1 point. The easiest way to do that is like it's going to touch the edge of the circle. So I'm going to let you get the definition down, and then we're going to pick a point off the circle, and we're going to do the edge to the point K. I know we got KI and KB, but we're not going to stress that. So let's say I'm picking this edge right here, this point on the circle. Okay? Pick a point, get a point on the circle. I'm going to do the bottom half, and I'm going to do the top half, okay? use your protractor because we're going to basically, and mine's going to be off a little bit. Let me fix it. I might be able to come at this angle. All right, so we want to connect, basically we want to go from this edge of the circle all the way out to K. So use your straight edge to connect your point from the circle to K. And notice that this line that we draw will not go through the circle. It's going to stay on the outside of the circle. So I did a point on the bottom. Let's do a point at the top too. I'm going to just pick a point. And I'm going to go from K to the edge of that point right there. Ooh, mine is way crooked. Okay, use your straight edge. You need to draw 2 tangents. And I'm going to start stamping to see if your diagram is complete. Yeah, this one's right. This one's going to have to come out a little bit. Make sure it doesn't go through. You see how it went through right there? All right. That one's right. This one needs to kind of come off. It's not going to go to K.
Yeah, I know how to do it.
Yeah, you're good. All right. 2 tangents. Make sure you have 2. Mm-hmm. Mm-hmm. Okay. Yeah.
Should the arrows be right here or here?
They're going to be on both sides.
Okay.
Yeah. Mm-hmm. Do you have yours? You have one drawn? Let me see it. Snap. If you're done, I can go in the tray. It's gonna be graded tomorrow. You gotta do the tangent. All right, so on the second part, on the next page, just flip it over. It's already going to be drawn for you. We're just going to read the diagram and list the examples of each type of part to the circle. So, anyone recall what a central angle is? Think about central, center. What do you think a central angle is? Okay, and angle, that's the symbol for angle, at the center. I know you mean by middle, you mean center. Okay, so get that down, an angle at the center, and I want us to look at, I'm going to minimize these a little bit. Nope, that's too much. Okay, let's look at our figure. Can you find an angle at the center? And let's name it. Okay, that's just the center. I'm going to do the angle symbol. I need 3 letters to identify that letter. Huh? All right, B, Q, C. Okay, if I go to B, Q, C, yes, that is at the center. So you put the angle symbol, and then you do B, Q, C. That is one. Anyone see another at the center? Yes, angle symbol, B, Q, and A. Yep. That's also at the center. So that angle there. And then, oops, I'm going to go right underneath so we have room. Angle AQC is the last one, right? Here. All right, so we have 3 angles at the center. Okay, we see those angles. That's review from last week. Now, we're going to do a tangent. A tangent is what? What makes up a tangent?
A line that intersects the circle at a time.
Okay, it is. Tangent is a line. Oops. That intersects the circle at 1 point. All right, so find a line. Remember that line has to look on the outside of the circle. It can't go through the circle. Find a line that intersects the circle at 1 point. I don't know. Yeah, I can do from right here, A to D. Okay, right there. It only touches the circle at A. Does everyone see that? So I would put AD, and then I would do the line symbol above it to show I'm talking about that line.
Where's D?
D's the point up. It looks like a O. It's a D. And CD. Okay, put CD with the line above it. All right, now, there are some properties to a tangent. So if I look at this tangent DC, and I look at this part QC, QC is what of the circle? The radius. I'm going to just put a little R there. Does anyone remember from yesterday what happens when the tangent meets the radius? Look at the second page of your packet. We did this yesterday. It is the point of tangency, and it makes, yep, that right angle, okay? So you need to add the box to show perpendicular, show the right angle, and show that the tangent that we have is perpendicular to the radius. So we have a box at C, and we're going to draw one at the A, okay? So our tangent AD, we're going to add this to our example, is perpendicular to AQ, to that radius. And CD would be perpendicular, that's the symbol for perpendicular, to QC. That's the property of a tangent. It's going to be perpendicular. It has to make the right angle. All right, so those are the examples for central angle and tangent. Then we're going to do secant. What is a secant? What does a secant do? Line intersects, yes. Circle. Okay, what makes it different from a tangent? Because a tangent intersects a circle. Yeah, at 2 points. At 2 points. 2 different points. Okay. So we need to find a line that's going through the circle, intersecting the circle at 2 points. Yeah, DB will work. So we write D, B, put the line symbol above it. I'm going to scroll this up so y'all can see what I'm writing. Oops, where are we at? There we are. All right, DB. Look at your figure. Is there another secant? Yeah. Yeah, AB. AB is also a secant. Okay, so we list those examples. All right, Conehead Theorem. We did this yesterday as well. Do me a favor. Add a circle. Put a point above the circle. We're going to label that point A. We're going to draw a tangent to the circle from A. That intersection is going to be B. And draw a tangent from A to the other side. And that's going to be C. Basically, we gave our circle a little hat, right? You see how we kind of created the cone head? All right, what happens, or what do we know about these two tangents? They are congruent. This tangent is congruent to that tangent. So the Conehead theorem is two congruent, yes, tangents. I'm running out of room. Two congruent tangents from the same point. They have to come from the same point, and they'll be congruent. So look at your figure. Do you have an example of the Conehead theorem?
Yeah.
Which two tangents? A and D is congruent to D and C. Yes. Those two tangents would be congruent. All right, so you should have everything up to date. Check with your group members and make sure you have your table filled. Your first 2 pages we did yesterday are completed. That goes in the tray.